Let's talk about number 8. Okay, we're going to try to talk about domain of rational function and vertical asymptote and Hall. Okay, so basically, like whenever you find the domain of the rational function, and all those are candidate for the vertical asymptote and Halls. Okay, some of them is the vertical asymptote and some of them is Hall. Then how can you decide like it is vertical asymptote and Hall? It is very easy. And from the out of domain, which make your denominator equal 0, that point uh, can be canceled out with numerator that is a whole. Okay, if it cannot be canceled out with numerator, then it is vertical asymptote. Okay, so we're going to start from finding domain. Okay, there we go. So to find domain, and we have to do the factoring numerator and denominator both of them. Okay, so this one, well, numerator cannot be factored. Okay, and that's enough. But denominator, let me put out negative first. It might be way easier. And like this way, minus, and this one is working with x minus 1 and x plus 2, right? Then we can say, like, we're going to answer by the domain interval notation, okay? So domain is what? As you practiced before, we can use number line, and you can easily find minus infinity to minus 2 and minus 2 to 1 and 1 to infinite. That is my domain, okay? And look at that. As I told you, we have like two undefined points, right? Which is 1 and negative 2. And all those points cannot be canceled with numerator. Then, like all those are the vertical asymptote. For this problem, there is no hole, okay? So vertical asymptotes are x equal to 1 and negative 2. Okay. And what about b? We're going to do the same thing, okay? And since it is rational function, we're going to do the factoring for your numerator and denominator, both of them, okay? So they can be by x minus 1, x plus 1. I strongly recommend you have to remember this factoring, okay? Is the difference of squares, right? And denominator, it is x plus 1, x minus 3, okay? Let's talk about domain first, okay? So domain is the undefined point of your like rational function, which means x equal to negative 1 and 3 cannot be your domain, okay? So domain is from minus infinity to minus 1 and minus 1 to 3 and 3 to infinity, okay? So now we have two candidates for vertical asymptote and Hall, okay? Which is negative 1 and 3. But look at that. Your negative 1 term, which is x plus 1 factor, can be canceled out with numerator. Then it is not the vertical asymptote, but it is a Hall, okay? So my only one vertical asymptote is x equal to 3, and we have Hall at x equal to negative 1, okay? Well, we will discuss about how we can find the exact position of Hall in calculus or pre-calculus class, okay? So now let's talk about C, okay? We'll do the same thing, okay? Do the factoring for your numerator and denominator, both of them, okay? So that is equal to x minus 5, x plus 5 over, well, denominator, we're going to start from, put out the common factor x, okay? x squared minus 6x plus 5, which is x minus 5, x plus 5 over x and x minus 1 and x minus 5, okay? So we can easily find domain, okay? So x cannot be equal to 0, 1, and 5, okay? So domain is minus infinity to 1, or 0, 0 to 1, and 1 to 5, and 5 to infinite. This is the interval notation domain, okay? So look at that. Like we have like three undefined points, right? 0, 1, and 5, okay? But 5, which is x minus 5 factor, can be canceled out with numerator, which means that is not a vertical asymptote, but it is a Hall, okay? So here we go. So your vertical asymptote is x equal to 0 and 1 only. Then we know the Hall is at x equal to 5, okay? So again, we will discuss about how we can find the y component of whole in calculus course, okay?